So here is a problem. Two identical springs, each with a spring constant K. So there's two identical springs, so and they have the spring constant K, for which the value is already provided. It's 220 Newton per meter. Are connected to a trolley and fixed supports. So these are the fixed supports, right? So they are not going to move. When the trolley is in equilibrium, the springs have their natural length. So trolley is probably in the middle, and their spring is in natural length. So there's no force provided by the spring in that case. It's asking calculate the net force on the trolley when it is moved 2 centimeter to the right. Okay. So now the trolley is moved 2 centimeter to the right, which means the spring on the right hand side will get compressed. Okay, it will get compressed, right, by 2 centimeters. And spring on the right hand side will get stretched, okay, by 2 centimeters. Okay, hence the trolley will move from the equilibrium position by 2 centimeters. Okay, and we have to find what is the net force on the trolley. Okay, so focusing on the horizontal direction, right, because vertical direction the force is balanced, right, with a normal reaction and mg. So we have to draw the free body diagram, okay, like this. So this is our trolley. When the spring is compressed, it is going to apply a force which is going to be in this direction, right? So that's going to be force number, call it A and B, force because of spring A, right? It's going to apply a force like that. And when the spring is stretched, it is also going to pull the trolley in this direction, and that is going to be force due to spring B. So the net force is going to be F net, right? And both of them towards the left. So FA plus FB towards left. Okay. So this is going to give us a direction. All we need to find is FA and FB at the magnitude. Because both of them are getting compressed same and they have the same K. That force we know has a magnitude which is equal to Kx, right? So K is 220 Newton per meter, and the x is 2 centimeter, which we need to convert into meters. So that's going to be 2 divided by 100 meters. So this and this will cut. So we'll get 22 into 2, which is going to be 44 divided by 10. It's going to be 4.4 Newton. Okay, so this is a meter. This will cut. 22 into 4, 22 into 2, that will be 44 divided by 10, 4.4 Newton. Both of them are 4.1 Newton. So we'll get 4.4 plus 4.4, and that is going to be 8.8 Newton towards left. Okay, because the force we need to provide the direction. So this is the magnitude and this is the direction. So we have now solved that part. Now we move to the part B. For the part B, I'm going to erase all this and see what the question says. Okay. The part B says when the trolley is in equilibrium, its spring is already extended by 4 centimeter. Okay. So for the trolley is in equilibrium, the spring was already stretched or extended by 4 centimeters. Okay. Now the trolley is moved 2 centimeter to the right. What is the net force? Okay. So we are going to draw again. So what it is saying that spring was already stretched, right, by 4 centimeter. This and this was a trolley. It was already stretched, right, by 4 centimeter. Okay, so when this was stretched, right, this is going to pull it in this direction, and this was also stretched. It was going to pull in this direction, which means the body was in equilibrium. Now we are going to move this one by the 2 centimeters. So what happens? If we move it by 2 centimeters, this side will get stretched by 6 centimeters now, right? And this block will move like this, and this side will now get compressed from 4 centimeter to 2 centimeters. And now we have to see how much is the force going to be. Okay, so if I draw the free body diagram now, the force because of, let's call it A and B. Now this one is compressed, right? So the force because of A is going to be on the left hand side, right? This is compressed. And this one is stretched, right? It is already stretched. So this is also going to apply a force in this direction, and this will be FB. This time, because the stresses are different, right, we'll get different forces. So we are going to call it F net, right? Again, both of them on left hand side. So we say FA plus FB, right, towards left. Okay. Now what is going to be FA? FA is this one. So that's going to be KX. So K is 220, right? And my X is 2 centimeter. So 2 divided by 100. So we are going to get exactly what we got in the earlier case was 4.4. Okay. How about FB? FB is now 6 centimeter stress. So we are going to get 220 into 6 by 100. So this and this will cut. And now we'll get 22 into 6 divided by 10, which is going to be equal to 22 into 6 divided by 10, 13.2. Okay, so 13.2. We add up 13.2 with 4.4, that is 17.6. Both of them in the same direction, so this is 17.6 Newton towards left, right? We need to mention the direction because that is the force.